Welcome in Tilco Advisors. We empower construction material manufacturers with cutting-edge digital solutions. And now, welcome to our podcast, where we share...
Imagine buying a brand new car, right? But the manufacturer outright refuses to tell you if the engine block was cast from recycled tin cans or like aerospace grade steel.
Oh, you wouldn't even consider it.
Right.
Mm-hmm.
They just hand you the keys, point to this shiny green sticker on the bumper that says eco-friendly.
Yeah.
And they expect you to just drive off the lot.
That lack of transparency would be an immediate deal breaker for any rational buyer. I mean, immediately.
Instantly. Yet every single day we spend, trillions of dollars building skyscrapers and hospitals and residential developments filled with materials that have completely hidden histories.
Mm-hmm.
We accept these massive, sometimes really toxic environmental footprints just because it's all wrapped up in a clean, modern facade.
Mm-hmm.
We walk past these heavily engineered construction sites and we see progress. But underneath it all, we're dealing with a staggering lack of basic material truth.
The cognitive dissonance in the construction sector it's really been remarkable. We demand absolute traceability for a $5 cup of fair trade coffee, Rushdie.
Yeah, exactly.
We want to know the exact farm the beans came from. But for a $50 million commercial high-rise, historically, the industry has just settled for a glossy marketing brochure and a whole lot of blind trust.
Welcome, everyone, to another deep dive. Today, we are tearing down that facade. We're looking at the construction industry's radical, really forced evolution from vague green marketing to strict, verifiable digital tracking.
Mm-hmm.
If you work anywhere near supply chains or real estate or sustainability, the rules of the game are about to fundamentally change, and you really need to know how.
Yeah, they are.
Our sources today are dense but absolutely fascinating.
Yeah.
We are pulling from academic papers via PLOS and preprints.org, official policy roadmaps from the European Commission, and some really critical industry implementation guides from Plan B Eco, Co-Builder, and ZVEI.
Right, and our overarching mission today is to unpack a singular transformative technology, which is the Digital Product Passport, or DPP. We are going to examine why regulators have basically lost their patience and are forcing this on the construction sector, how the underlying architecture actually works out in the field, and how this permanently shifts an entire global industry from relying on trust me marketing to here is the mathematical proof reality.
Okay, let's unpack this. Before we get into the high-tech solutions, the QR codes and the decentralized data structures, we have to understand why the hammer is coming down so hard right now. Why couldn't the construction industry just police itself?
Well, to understand the intensity of the regulatory scrutiny, you really just have to look at the sheer physical reality of the number. They're borderline apocalyptic when you aggregate them.
Yeah.
In the European Union alone, the construction sector generates roughly 35% of all waste.
Wow.
And if you zoom out further, the industry consumes about 50% of all extracted raw materials globally.
That is wild. Half of all global extraction.
Half of everything we pull out of the earth goes into our built environment.
And based on the sources, it's not just an EU issue, right? The data from New Zealand paints a pretty grim picture of the global standard.
Yeah, the New Zealand data is a perfect microcosm of this systemic failure. Down there, construction and demolition create 40 to 50% of all their landfill waste.
Oh, man.
Just building one single standard new home produces about 4 tons of waste.
4 tons for one house.
For one house. And then you have to factor in the materials themselves, specifically concrete. Concrete production alone contributes 1.4 million tons of greenhouse gas emissions annually in New Zealand.
Jeez.
And when you look at the built environment as a whole, factoring in the entire life cycle of manufacturing and building and operating these structures, it accounts for 3/4 of annual global greenhouse gas emissions.
3/4. So we have an industry that is incredibly resource intensive and highly polluting. But if you look at the marketing for construction materials over the last decade, everything has a green leaf stamped on it. Everything claims to be eco-friendly or sustainably sourced. If the math is that bad, how has the industry historically gotten away with painting itself so green?
They managed it through what our sources, specifically the DigiProdPass documentation, they explicitly define it as greenwashing. Greenwashing is when a company makes vague or exaggerated or outright misleading environmental claims to appear more sustainable than the math actually supports.
Oh, yeah.
And it thrives in an environment where there is no mandatory data verification.
Right. It's the classic We dumped toxic sludge in the river, but we planted a single tree in a parking lot,
Yeah.
so we're carbon neutral strategy.
Exactly. That is essentially the carbon neutral by offsets tactic, which is heavily criticized in the literature. It implies a product has zero impact simply because the manufacturer bought some cheap carbon credits,
Right.
rather than re-engineering their process to cut actual manufacturing emissions. But the DigiProd Pass source lays out even more insidious tactics. You have the rampant use of private eco-badges, which look official, but they lack any independent oversight. Or the most common tactic, which is cherry picking.
Where they heavily advertise one single green feature, like a fully recyclable plastic cap on a chemical drum,
Exactly.
while completely ignoring the massive emissions generated to produce the core chemical itself. It's misdirection.
Misdirection is the perfect word for it. The marketing team focuses your attention on a minor positive detail just to distract from a major negative reality.
Well, to be fair to the engineers in the industry, there was an attempt to fix this before the new regulations came down. We had EPDs, Environmental Product Declarations. But based on the preprints.org and PLOS studies in our stack, EPDs failed because they were essentially optional, easily manipulated PDFs living in these completely disjointed databases.
Yeah, the intention behind EPDs was solid. They were meant to provide a life cycle assessment, evaluating a product's environmental impact from the extraction of raw materials to its eventual disposal. But the execution was severely flawed. The preprints analysis highlights a critical lack of standardization in how data was collected and reported. Because it was largely voluntary, different manufacturers used completely different methodologies to calculate their footprints.
So relying on early EPDs was kind of like reading a movie trailer instead of watching the actual film. The manufacturer only showed you the absolute best scenes, they left out all the messy plot holes, and you never really knew if the story held together until it was too late.
That's a great way to put it. The lack of comparability made them functionally useless for high-stakes decision-making.
Right.
If an architect is designing a high-rise and wants to compare the carbon footprint of two different steel beams, they can't make an informed choice if one EPD strategically leaves out the massive transport emissions from shipping it across the globe, while the other honest EPD includes them.
Wow. Yep.
Furthermore, the databases where these declarations lived, like Okabadot in Germany, were just fragmented data silos.
So regulators realize that you can't just ask an incredibly lucrative industry to be honest on a voluntary basis. You have to architect a system where lying, or even just omitting the truth, is mathematically and legally impossible.
Well, exactly.
That meant stripping away the voluntary paper trail entirely and replacing it with a mandatory, permanent digital identity.
This is the core of the European Union's new approach. Under the Eco-Design for Sustainable Products Regulation, the ESPR, and the newly revised Construction Products Regulation, the CPR, we are seeing the birth of the Digital Product Passport.
So let's break down the physical reality of the DPP. What does this actually look like on a construction site?
So the DPP is a highly structured, mandatory digital record that captures key information about a product's raw materials, its verified environmental performance, and its end-of-life instructions. Crucially, this digital record is irrevocably tied to the physical product via a data carrier.
Okay.
We are talking about a QR code, an RFID tag, or a data matrix etched directly into a steel I-beam or printed permanently onto a roll of industrial insulation.
The DigiProd Pass source calls this the shift from the trust me era of marketing to the check it yourself era.
Yeah.
I'm picturing a site manager walking up to a freshly delivered pallet of materials, pulling out a tablet, scanning the QR code, and instantly seeing not just a marketing brochure, but the exact carbon footprint per square meter, the specific repair instructions, and like the chemical breakdown of the adhesives used.
Traceable, data-backed facts replacing vague claims. And we are well beyond the theoretical phase here. There are real-world pilots executing this right now.
Oh, really?
Yes. The Co-Builder and PLOS sources detail a major initiative called the Surface 2 project. They are currently piloting live DPPs on construction components in the field.
I was looking at that Surface 2 pilot, and it really stood out to me that they chose concrete staircases to test this out on. Out of all the incredibly complex mechanical and electrical systems in a modern building, a staircase seems almost too simple. I have to imagine that was highly intentional.
It was a very deliberate choice for a proof of concept. A staircase is a discrete, closed unit element. It doesn't have moving parts or complex electronic integrations, which makes isolating and evaluating the environmental data much cleaner.
Right.
In the PLOS study, Researchers used this prototype DPP to present consumers and decision makers with a direct comparison between two types of staircases. One made from natural aggregate concrete, or NAC, and one made from recycled aggregate concrete, RAC.
And the psychological findings from that study are fascinating. Because the barrier to buying green isn't always cost, right?
Wow.
Often it is simply a deep-seated lack of reliable information. The study proved that when decision makers are presented with transparent, easily accessible, verified environmental data via a DPP, their acceptance of the sustainable product, the recycled concrete, goes up significantly.
The data removes the risk.
Yeah.
If a contractor knows definitively that the recycled concrete meets all structural requirements and has a vastly superior carbon profile, the decision becomes obvious.
And the clock on this transition is officially ticking. According to the Plan B Eco Guide, this isn't some distant utopian goal set for 2040. As of January 8, 2026, the new construction products regulation started taking effect.
Exactly.
For priority categories like cement and structural steel, calculating and reporting your global warming potential, your actual verified carbon footprint, is now a mandatory inclusion for getting a CE marking. You literally cannot sell these products in the European market without it.
What's fascinating here is what is particularly critical for businesses to understand, and that's the immediate knock-on effect. Companies that fail to digitize their life cycle assessments are already facing exclusion from public tenders.
Wow.
If a manufacturer wants a lucrative government contract today, they need the digital proof right now. The regulatory shift has forcefully dragged sustainability out of the marketing department and dropped it squarely into the laps of core IT and compliance teams.
Well, let's talk about the physical reality of that IT burden for a second, because I have a major question here. If I'm a manufacturer, say I've spent a decade and millions of dollars developing a highly proprietary, low-carbon steel recipe, the absolute last thing I want is my exact material composition and deep supplier data floating around on some massive public EU database for my competitors in other countries to scrape and copy.
Of course.
Also, if I'm a small, family-owned lumberyard in Sweden, I can't afford a massive enterprise IT overhaul. How does this system not just immediately crush small businesses and destroy trade secrets?
Well, that dilemma was the primary point of friction during the drafting of these regulations. The fear of intellectual property theft and the administrative burden on small and medium enterprises, or SMEs, were massive hurdles.
Right.
The solution, which is heavily detailed in the Build UP feasibility study and strongly advocated for in the ZVEI industry pager, fundamentally shifts how we think about data storage. There will not be one giant centralized mega database sitting in a server farm in Brussels.
Oh, okay. So where does all this highly sensitive data actually live?
The consensus architecture is a decentralized model. Manufacturers will host their own databases, or, more likely for those smaller SMEs you mentioned, they will contract authorized, qualified software service providers to host it for them.
I see.
The data remains under the physical and legal control of the creator.
But wait, if the data is fractured across thousands of different manufacturer servers and third-party software providers, how does anyone actually access it?
Through a highly structured protocol of identity and access management, the DPP is designed to operate strictly on a need-to-know basis.
Need to know.
Yes. When a general consumer or a building contractor scans that QR code on site, their permissions only allow them to see the public-facing information: the carbon footprint, the safe handling instructions, the recycling steps.
The stuff you need to safely use and eventually dispose of the product.
Exactly. But the confidential technical documentation, the proprietary chemical recipes, the sensitive supply chain contracts, that data remains locked behind secure access walls.
Oh, wow.
It is only accessible to market surveillance authorities, and even then, usually only upon a justified legal request. This decentralized, permission-based system protects trade secrets while still allowing the EU to verify compliance.
Here's where it gets really interesting. If everyone is allowed to use their own third-party software providers, how do we make sure all these different databases can actually talk to each other?
Right.
Let's say an Italian window maker uses an Apple-based inventory system, and a Swedish steel mill uses a bespoke Windows program from 10 years ago. How does the contractor in France use one tablet to read both passports seamlessly?
That interoperability relies entirely on underlying standardized digital frameworks. The European Union isn't dictating what software a company has to buy. They are dictating the foundational language that software must speak.
Okay.
The primary framework mentioned across our sources is the Asset Administration Shell, or AS.
I think of the AIS like a universal translator. Imagine all these different materials showing up at a site speaking completely different digital languages. The AAS acts as that universal translator plugged directly into the QR code, ensuring that no matter how the original data was formatted on the manufacturer's server, it is structured in the exact same modular format when it hits the French contractor's tablet.
The universal translator analogy is spot on. It guarantees technological neutrality. And alongside the AAS, the system utilizes EPCIS standards.
Yeah. And EPCIS is essentially event tracking code, right? Similar to how FedEx tracks a package from a warehouse to a delivery truck to your front porch.
Exactly.
The EPCIS standard ensures that a steel beam's journey, when it was cast, when it was shipped, when it was installed, is seamlessly logged at every single stop.
It creates an unbroken chain of custody. Solving the data storage and communication problem isn't just about protecting trade secrets during construction, though. It is about ensuring this vast trove of data survives for decades.
Which brings us to the real end game of this entire regulatory push. Let's zoom out and look at the actual timeline of a commercial building. We aren't just tracking materials for a 2-year build, we're tracking them for a century.
Yes. The true value of the DPP system doesn't fully materialize until the building reaches the end of its life. A typical commercial structure or residential block might stand for 50, 80, or 100 years.
Yeah.
Historically, by the time that building is slated for demolition, the original architectural blueprints, the specific material specifications, and the maintenance records are entirely lost.
Right.
They were thrown out in a filing cabinet purge decades ago, or they're trapped on a corrupted hard drive.
So when the wrecking ball finally shows up 50 years later, the demolition crew has no idea what they're actually smashing into. They treat the entire building as generic, potentially hazardous rubble.
Exactly.
It all just gets scooped up and dumped into a landfill because they don't know the structural integrity or chemical makeup of what's inside.
The loss of information directly causes the physical waste. But under the new digital ecosystem, the DPPs of every individual product, the windows, the doors, the concrete slabs, the steel beams, they are preserved.
But how does that data actually get from the physical beam into a long-term storage system? I mean, does some poor intern have to sit in a trailer manually typing all these QR codes into a spreadsheet at the end of the project?
No. The integration happens in real time on the construction site. As materials arrive and are installed, they are scanned.
Okay.
When the crane drops a steel beam onto the 5th floor, the site manager scans it. At that exact moment, the software pulls the beam's passport from the manufacturer's decentralized server and permanently snaps it into the 3D digital model of the building, often a building information model, or BIM.
So the building essentially builds its own digital twin in real time as the physical pieces are locked into place.
And that aggregated data becomes the digital building logbook, the DBL. The building itself gets a master passport made up of thousands of individual component passports.
Wow.
The DBL serves as a single, immutable source of truth for the entire structure throughout its entire century-long life cycle.
Which fundamentally changes what happens when it's time to tear it down.
Drastically. Decades from now, before a demolition crew is even allowed on site, we will see the implementation of mandatory digital pre-demolition audits.
Meaning you can't just swing the wrecking ball and sort it out later.
Yeah.
You have to digitally audit what you were destroying before you touch it.
The authorities will use platforms like DECRARA, the Digital European Construction Resource Assessment, because every single material in that building has its data perfectly preserved in the DBL. The demolition teams will know exactly which high-grade steel beams can be salvaged and reused, which concrete slabs can be safely crushed for recycled aggregate, and precisely where legacy chemicals are located for careful extraction.
If we connect this back to those apocalyptic waste statistics you mentioned at the beginning, the 40 to 50% of landfill waste in places like New Zealand, this is the actual mechanism to fix it. You stop treating a demolition site like a trash heap, and you start treating it like a hardware store.
If we connect this to the bigger picture, this is the European Commission's ultimate strategy to force the construction industry out of the linear take-make-dispose model and into a true circular economy.
Yeah.
The building essentially becomes a localized material bank, storing valuable resources for future construction projects.
It is a massive paradigm shift. We started this deep dive looking at a highly polluting industry hiding behind vague green leaves, carbon offsets, and fragmented, really useless EPD databases.
Yeah.
And now we're looking at a heavily regulated, completely transparent ecosystem. a decentralized network of universal translators tracking every ounce of carbon and every recycled aggregate, from the factory floor to the construction site to a demolition audit, 80 years in the future.
The level of accountability being architected right now is unprecedented in modern industrial history.
It really is. And before we wrap up today's deep dive, I want to leave you, our listener, with a thought to mull over. Something that builds on everything we've just discussed about digitizing the physical world, but takes it one step further.
The implications for the financial sector alone are massive.
Exactly. Think about this. If every physical brick, every steel beam, and every window pane now carries a permanent, legally verified digital twin detailing its exact material worth, its carbon history, and its future recycling potential,
Right.
could we eventually see an entirely new kind of stock market emerge?
A commodities exchange based on embedded materials.
Yes. Imagine a marketplace where high-grade building materials are traded like traditional commodities or carbon credits, while they are still physically bolted inside the walls of a standing building.
Wow.
Valuing the future recycled materials years, maybe decades, before the demolition even occurs, purely based on the absolute trust in that DPP data.
It redefines the concept of real estate. A building wouldn't just be valued for its location or its rental yield. It would be valued as a literal financial asset of raw materials waiting to be harvested.
It really makes you look at that pristine, highly organized construction site we talked about at the beginning in a completely different light. It's not just a building going up, it's a massive physical hard drive of environmental and financial data being meticulously assembled piece by piece. Keep questioning the world around you, and thank you for taking this deep dive with us.
That's it for today's episode. We hope you enjoyed exploring how digital workflows are transforming the construction industry. Don't forget to subscribe and join us next time for more insights into building smarter. Head over to our website. You'll find everything you